Welcome back, innovators, to another explainer. We're here to bridge that gap between abstract ideas and real practical execution. I'm your host, and of course, right over there at the high-tech data screens is our lead innovation catalyst, looking sharp in his signature red shirt and glasses. We are absolutely thrilled to have you with us today because, well, we're going to completely transform how you look at the flaws, defects, and waste in your everyday projects. Let's just quickly align on the foundation of what we do here. As our catalyst is tapping on the screen, you'll see we utilize TRIZ. That's the theory of inventive problem solving. You know, we really need to break a super common myth right off the bat today. True innovation, it's not some random eureka moment that just magically strikes from the sky for a lucky few. No way. It is a highly repeatable architectural discipline that literally anyone can master to solve everyday contradictions in their specific fields. It's a systematic process, plain and simple. So if you're ready to stop relying on luck and start mastering systematic discovery, hit that subscribe button to join the Idea Mechanics team. And don't forget to ring the notification bell so you're the first to see our next innovation breakdown. We want to build this culture with you. Drop a comment below and tell us which TRIZ principle or tech challenge we should tackle next. Okay, let's dive into this. What if the very defect you are spending millions to polish away is actually your greatest asset? I know, it sounds completely counterintuitive, doesn't it? In our professional lives, we're so deeply conditioned to view manufacturing flaws, anomalies, and byproducts as the ultimate enemies, things that just have to be destroyed. But today, we're going to challenge that assumption entirely. Check out this stark contrast our navigator just pulled up. On the left, you've got the old way, what we call the waste management trap. This is where engineering and manufacturing teams drain massive budgets, trying to scrub, polish, or just vent away process flaws and waste heat. It's a purely reactive, trial and error kind of mindset. But then, look on the right. We have the TRIZ way, waste transformation. This is the proactive, systematic discipline of turning system liabilities into high-value strategic assets. We aren't just mitigating the bad stuff here, we are entirely transforming it. Now, what's really interesting about this slide is the formal definition of the technique we use to achieve this. It's called TRIZ Principle 22, blessing in disguise, or, as it's more practically known, turning lemons into lemonade. It's all about intentionally finding a positive use for what is typically considered a harmful or undesirable factor. This specific mindset shift is incredibly powerful. Seriously, it's the very engine that drives circular economy innovation all around the globe. Section 1. Case Study, the perfect flaw, additive manufacturing and heat exchangers. So the problem here is a well-known phenomenon called the staircase effect. As our expert is pointing out on the data screen, in 3D printing, objects are built layer by layer, right? And that naturally creates a rough, textured surface finish on the final part. Traditionally, everyone in the industry just assumes this roughness is a massive liability. It's viewed as a defect that demands incredibly costly and time-consuming post-processing, like intense sanding or chemical polishing, all just to achieve a perfectly smooth wall. And this brilliantly illustrates the exact moment of systematic discovery. When you're designing a heat exchanger, a larger surface area is highly desirable because it facilitates far more efficient thermal transfer. So instead of fighting the 3D printing process, innovators applied Principle 22. By intentionally keeping that rough, staircased texture, engineers dramatically increased the surface area compared to a traditional polished wall. They completely eliminated that costly post-processing step and, at the exact same time, created a vastly superior performance-enhancing product. They literally weaponized the flaw. How cool is that? Section 2. Case Study, Recycled Energy. Industrial waste heat recovery. Here is the core contradiction these major industries face. Heavy industrial processes generate absolutely massive amounts of waste heat. Historically, the standard operating procedure is simply to release this heat straight into the environment. It represents a severe, painful loss of energy and contributes heavily to thermal pollution. Treating this thermal output as just an annoying operational cost to be vented away, well, that is exactly the kind of reactive, trial and error mindset we want to leave completely behind us. Let's move to and see how this builds into a brilliant architectural solution. Watch as our catalyst gestures through the energy flow here. Step 1. The industrial process inevitably generates intense waste heat. But at step 2, instead of venting it into the sky, we capture it. Step 3. We redirect that exact thermal liability to drive a secondary steam cycle, which leads perfectly into step 4, generating combined heat and power. We are literally creating new electricity from what was previously considered pollution. The problem actually becomes its own power source. Section 3. Weaponize your industrial waste, the systematic discipline of efficiency. So the crucial point is this. To truly master this blueprint, you must stop fearing system anomalies and byproducts. Understand that intentional reframing, looking at your problem from a completely different angle, turns your biggest liabilities into fresh revenue streams. Because true efficiency is not an accident. It's not some random stroke of genius. It is a repeatable, analytical skill that you can start applying today. As we wrap up today's session, I want to leave you with this final, really powerful question to challenge your workflows. If true innovators don't just clean up waste, but actually weaponize it for success, what hidden asset is sitting inside your biggest operational flaw right now? Think deeply about it. Apply these systematic mechanics, and let's keep building this culture of innovation together. See you in the next explainer.